So let's come to the part of stress and strain. Now, stress and strain are put into solid objects. Now, the first thing that you have to know is they are applied into solid objects. Solid objects. Now, the common doubt among students is the difference between stress and the difference between strain, and how to identify and how then to solve the questions. So the answer should be you should know the conceptual definitions of stress and strain, and then you should proceed with the chapter. Now by definition stress is nothing but the magnitude of force per area. That is magnitude of force per area. Now, this is the definition of stress. Now, let's understand this stress physically. Say, suppose you have an object. And you apply a force F to it. So, even though you are applying force at this particular point, but since these are solid object and the molecules are attracted to each other, so because of the applied force F, all the other particle experiences a deformative force, as I've mentioned in my previous video about deformative forces. So a deformative force, that is, it is trying to deform the body. A deformative force is generated, and in order to maintain its shape, because it has an elastic property, so in order to maintain its shape, it applies a restoring force. This is your restoring force. That is, the molecules want to go back to its equilibrium position. Now, why does it do so? Let me explain. So these are molecules which are equally placed. Now, if you apply a force over here, this molecule tends to come towards this particular molecule, because this is ground. So this ground molecule pushes this upward. So the center molecule gets compressed, and because of electronic repulsions and because of other other forces, they push each other. Each layer is being pushed by the lower layer, and therefore a restoring force gets generated. Now, sometimes what happens is that if you apply a force too hard, then sometimes the bond breaks and it forms into some other places. A bond that was in place here starts breaking and starts forming into some other equilibrium place where the experienced force is less. That's why sometimes we get a permanent deformation. But sometimes what happens is, if there is no permanent deformation, so a restoring force will be applied. Greater is the deforming force, greater will be your restoring force, until and unless it is permanently deformed. So this is what you can understand as stress. Now a force is being applied, and the restoring force that is being given, or the deformative force that is being experienced. For deformative force, all the other part that is giving, and for deformative force, all the particles that is experiencing. So if you say, what is the stress at this particular area? What is the stress experienced at this particular area? This is nothing but total force. This is total force that is distributed amongly by A. That is total force that is being experienced at a particular area A. This is the particular area A. Now, if you want to experience what is the force over here, you have to calculate, that is, what is the relative force that is being given over here. So if a force F is given, this part will experience the same force as this part. So stress is nothing but force divided by your area. This is what is you know as stress, and I hope the definition of stress for you has been a bit more clear. Now there are two types of stress. Say suppose this is a rod. Now if you try to pull this rod in opposite direction, then that type of stress that the object experiences tensile is tensile stress. That is, it's trying to elongate. Now, in the same manner, say this object, that is this rod, you are trying to compress. You are trying to compress. So that type of stress, that is the stress that is experienced because of this applied force for this area. Now please keep in mind, when you talk about stress, you're talking about the area. This area is defined by you. This area is defined by R, that is the person who is calculating. So if I want to find the stress for this whole area, then I'll take this whole area. If I want to find for this particular area stress, then I'll take the area to be my minimum. So for this whole area, the stress is given, or this type of stress is known as compressive stress. Compressive stress. So because of this too, there is a slight change in the length. Because of this compressive strength and the tensile strength, because we are pulling and we are pushing, there may be a change in length. Change in length. So if there is a change in length because of this type of stress that is experienced by the body, let that change be del L. First, initially this was L, the whole length was L. Now the change experienced be del L. So if I take the ratio of the amount that has been changed divided by the total length, then that type of equation, this type of equation that arises from stress, is known as strain. So now we are in a position to define what is stress and what is strain, and to concentrate on their fundamental differences. So for me, how I understand stress and strain is that stress is the action. And strain is the reaction. This is the reaction. This is how you can understand. Now, when you apply a force in a body, the body experiences a stress. That is, the body experiences a force along with its area. That is the area that we want. That is the whole area. The body experiences a stress. Now, because of this experiencing of a stress, the body undergoes certain deformation. Now, this deformation may be permanent or may be not. So, this deformation with respect to its original shape is your strain. How much has the shape changed? That is your strain. And how much is he experiencing force? So you can say this is action and this is reaction, and in this way you can understand what is stress and strain. Now another part is that, say suppose, as I've said, if this is a rod and there is a change in length, that is a change in vertical length, or if the rod was placed over here, this will be a horizontal change. So it does not matter which position, but if there is a change in length, then that type of change is known as longitudinal strain, longitudinal strain, and that is defined by del L upon L. Now, for example, say suppose this was the rod. Now, a force F is being applied over here and a force F is being applied over here. So now you can see if I fix this position, because of this force, there's a slight change. There's a slight change in the opposite surface area. In the opposite surface area, there is a slight change. Now you can see there's a slight change of del x. So that is del x. So the slight change. Now this type of change is also a strain. This type of change is also a strain. But this strain has another name. And that strain is called as shearing. Shear. This is shearing strain. And this is defined as del x upon L. This is the theta that is being displaced. Now what you can keep in mind is that shearing strain, this is shearing strain, is basically different from longitudinal strain. You may ask me the question, how is shearing stress different from longitudinal strain? Longitudinal strain is basically the change in the length, but shearing stress is basically the change in difference between the two surface areas. The change that is known as the shearing stress, or sometimes it is also known as tangential strain, because this is the change that is being produced in the tangent, that is in a direction of the tangent. So you can say that if two equal and opposite deforming forces are applied parallel to the cross section of the cylinder, this is parallel to the cross section of the cylinder, then there is a relative displacement between the opposite faces of the cylinder. When there is a relative difference, or there is a relative displacement in the opposite faces of the cylinder, this is your cylinder and this is your cylinder, that is face of the cylinder and this is face of the cylinder. So there's a relative displacement, as you can see. There's a relative displacement. First it was over here. The relative displacement was from initial, and then after applying the force, the final. So the change in position will give you the relative displacement. Then the restoring force is developed. As I've said, if you displace something, a restoring force is developed due to the applied tangential force, and that type of force is known as shearing strain or tangential strain. I'm writing this up in a proper way. Tangential strain, which is given by this particular formula. So now we have a definition of what is stress and what is strain, and how there are different types of strain. That is, one is longitudinal and one is shearing or tangential strain.